Hello, everyone, and welcome to the 2021 Hackaday Prize Dream Team final presentation event with Team EDGA, who's developing an open source hardware solution to combat the ghost gear in our oceans. My name is Magenta Strongheart, and I'm head of design and partnerships here at SupplyFrame's Design Lab. Thanks to our amazing sponsors, SupplyFrame and DigiKey, the Hackaday Prize and Dream Team program is able to continue supporting open source hardware development on hackaday.io. Please check that out for more information on upcoming prizes and contests. We're giving away a lot of money in November in just a couple weeks to our Hackaday Prize finalists, so keep an eye out for more news on that. Today, we're so excited to have special guests Rob Ryan Silva, DAI Maker Lab Director, and Andrew Lamb, Global Innovation Lead at Field Ready, also a Shuttleworth Fellow and CEO of Massive Small Manufacturing, joining us today for our discussion with Team EDGA. Without further ado, I'm going to pass it off to Giovanni Salinas, our product development engineer, to introduce us to our two Dream Team members who will be presenting on today's call.
Thank you, Magenta. And hello, everyone. Thank you to our guests for being here today. You're awesome. We're really happy to have you here. So we're here for the final presentation of Dream Team EDGA. The team includes Erin in Canada and Leonardo in Venezuela. This time around, the team flew solo and carried on with product development on their own. There are a lot of improvements and fixes to talk about based on the learning from the first iteration. So yeah, I'm really excited to pass the microphone to the team so they can explain to us the objectives of the project and their progress. So the microphone is yours, team.
All right, thanks so much, Gio. And can everyone see the screen? Okay, great, thanks. All right, so here we are today to present the progress that we've made on EDGA version 2. All right, so just to back up a bit and give a bit of a background of this project, the objective of EDGA is to reduce whale entanglements. So when fishers are gathering their catches, such as lobsters or crabs or cod, what they do is they send traps to the bottom of the seafloor, and those traps are marked on the surface using a buoy. So there's a line in between going all the way from the bottom to the top. This is a hazard for whales, especially in migration corridors. So we want to reduce the amount of time these lines are active. For fishers, when they think of ropeless fishing systems, they need a reliable release mechanism. It has to work every single time. As well, there's many operational costs for fishing. So that means that if they can have redundancy with multiple units, then this would make the transition smoother for them to ropeless fishing systems. Now, this problem takes place all over the world. And so in order to make this available, we plan on releasing the designs open source. All right, so first up, let's see what we have created over the past 2 months. All right, so that gives you an overview of the solution that we have developed in order to solve those problems. So just to go over again, what this is called is a ropeless phishing system. And the buoy is launched to the surface only after a certain amount of time or after certain sensor data. This means that we can reduce the amount of time that the vertical line is active. So AJA is comprised of an intelligent buoy, and it's rated for a depth of 100 feet right now using the current spool. It weighs about 7 kilograms, and internal to its buoy, it's equipped with GPS, LoRa, Bluetooth Low Energy, and it's powered by just one single 18650 battery. The estimated battery life is set to be 2 days, and internally it's magnetically coupled to an external wiper for the release mechanism. What makes this platform different than others is that we have the capability for additional sensor payloads, which enables the fishers to also conduct research as well as alongside their operations. All right, so let's break down what you just saw. How exactly does this work? The first step is the fishers set the timer on a web app. Then when they deploy their gear, the robot is deployed alongside, meaning it's attached also to the gear, and that's how it gets to the seafloor. Once that time has elapsed, that's when the buoy is launched. When it reaches the surface, then the GPS coordinates of the buoy is broadcast to the gateway, so that way the gear can be retrieved. So next up, let's see how this release mechanism works. The best part is that this release mechanism method is redundant in its operations, meaning the movement of the motor that goes to release the seatbelt piece that's attached outside of it, it can perform that movement multiple times. So if it doesn't work the first time, then it keeps repeating it for about 5 to 10 times. Now we will see the ascent of the buoy to the surface of the water. It's at this point when the buoy is on the surface of the water is when it will start to connect to the gateway and broadcast the sensor information such as GPS. So the design of this version of AJA was conducted in a way that it contains different materials for each purpose. And we tried to think of the best way of manufacturing for each of these pieces. So really trying to use 2D manufacturing methods, as they would be quite faster than, say, 3D printing. So if we're to break down the subsystems of this robot, again, it's comprised of the intelligent buoy, and that sits on the upper stage base. The upper stage also holds the sleeve bearings that have the external magnet wiper seat belt per se. Then also mounted to the underside of the upper stage is the spool holder. On the lower stage base is space for ballast, as well as the landing stands, which are extremely rugged. Both of these stages are attached together using corrosion-resistant threaded rods, which means that this can be modular in a way by adding in additional stages or by adjusting the height between the two stages to accommodate a larger spool size, being able to access deeper depths. As well, something that is not pictured here is a wooden deck that was created, and this is for transporting the device. It's a very small detail, but operationally, it's incredibly useful, whether you're bringing it to the shore for field testing or if you're loading it onto a boat for fishing. All right, so how did we reach this point? Well, it's all backed up with analysis. So for example, through the version 1 prototype, we learned about all of the pieces that link together to form the entire system. And there have been so many concept sketches throughout that time, as well as at the beginning of version 2. Then we also conducted a computational fluid dynamics simulation to analyze the system on its entry into the water. A physics model was developed in order to determine the weight to buoyancy ratio, the tension in the rope, the descent velocity, and the drag force. Most importantly, though, attaching the theory to the actual practice was learning from experts, such as the Design Lab Dream Team meetings with Giovanni. This actually saved us from many pitfalls throughout the design journey. Okay, so how are we going to evaluate what we created in terms of what is useful for fishers? Well, the Canadian Wildlife Federation, they noticed all of this development for ropeless fishing systems, and they created a framework to classify these systems based on functionality that's critical to fishers. The areas where AJA is the strongest is durability, the safety to use it, being easy to reset, and also easy to store. With additional software development, we believe that we can also meet the detectability of traps and enforcement and monitoring. Now over to Leo to tell you all about the cost and electronics.
Thank you. Great. So let's start discussing the overall cost. Now let's get straight into that. The cost of the overall of the set that we are describing is we have measured it in $2010.46. That is US dollars, and this cost describes different elements of the set of the components that we have been describing. And of course, we are also considering one set and the way we assembled it and we handle the manufacture. So if we were to make larger productions, or if we were to make a streamlined way of production, that has the potential to reduce the cost. So right now, the cost that we are describing includes one gateway device that the fishers uses to communicate to a buoy or a different set of buoys. But in this case, we're also counting one buoy and one base. The buoy and the base, you can see, it can be seen on the bigger picture on the slide. we have the buoy and the base that is all the release mechanism. And on the smaller picture, we have all different components. Now let's break down the cost. We have 100 and, okay. Now let's break down the cost. We have 184 for the electronics, 326 for the hardware. Those are different elements that we had to buy and import to make different parts of the buoy and the base, and also raw materials and fabrication, also different parts of the base, and also like the way I described that we handle the fabrication. So the assembly overall took 15 hours. And hopefully we are going to be able in the future to reduce this if we manage to make a more streamlined production line. Now let's go to the following. Okay, so since we have already an experience from last year, this year, while we were trying to improve the design, maybe adding features or considering the features that we had or making a more robust design, we also tried to reduce the cost. And this is a representation on how we try to reduce the cost. One of these places where we managed to reduce it was in the electronics. We have 4 images. We have 2 associated to intelligent buoy, those are the 2 on the left, and we have 2 associated to the gateway. And we compare the prices from the design from last year to this year. Now, for the intelligent buoy, last year we have a design called Buoy B with $131, and now it's replaced for the design this year, EJA M, $108. And for the gateway, we have the onboard gateway that costs $84. Now it's replaced for the same design, EJA M, but with reduced features, because we managed to make we managed to make the same design, but depending on the components that you solder, on how you assemble it, you can have different functionalities. So we have a reduced version that is that has a lower price. Now let's go to the next one, please. Okay, so now let's discuss how which features we have and how is this new design that we presented. We have the new designs called EJA M. This is the third version. And the same way I mentioned, that PCB replaces the buoy and the onboard gateway, those designs from last year. And their main features are LoRa, GPS, and ESP32 for the microcontroller, a real-time clock to manage the timing operations that we have, a servo motor driver to manage the motor that moves the release mechanism, a battery charger that is always very important, and an accelerometer that is also related to the release mechanism. And like I mentioned, this same design can be soldered or can be assembled with a reduced amount of features for a lower price if we intend to use it for a different application. Now let's go to the next slide, please. Now let's talk a little bit on how it was the process this year to go from to improve the design. On the left, we have 2 PCBs, those 2 designs from last year. And we started from that we had last year. Those PCBs worked, they were functional. They included different products from different modules, the ESP32, other LoRa or other GPS. And we focused on removing or not using commercial modules, but developing the design of the electronics and the circuits ourselves. So basically we tested small versions of the circuit that is for the LoRa, for the GPS, the USB-C, the FTDI that we can see on the screen, the green PCBs. Those were our tests in order to get to the final design. That is the PCB that we have on the right, EJA M. Now let's, the next one, please. Okay, now we're gonna briefly discuss about the features. The new design is not super different from the last one. We already know that it has decreased the price, but also let's compare. The main features we have maintained them. So we are also having the LoRa, the GPS, the ESP32, real-time clock, and the servo. Those are the same features we had from last year, but we are not using DC motors this year, and we're not using 4G LTE this year. For this design, we included the battery charger and an accelerometer that was required during the release part, during the product is on the release, using the release mechanism. The next one, please. For the onboard gateway, and this is why I mentioned we can have a less expensive version because we require less features. For the release, for the gateway, we only require the LoRa, the ESP32, and the battery charger. We also had that last year, but this year we also included a real-time clock because we realized that the timing operations, the timing of the different parts of the different elements of the design, we require an additional timer to coordinate the operations in between the buoy and the gateway. Next one, please. Now, this is the user interface that we have. Right now on the gateway, the device the users carry with themselves, that device has a server and you can connect to it and change the configurations, get information, or see all the information through your phone. So this web page that you can access, it allows you to set the timer for each buoy, track the different positions, that means get the information from the GPS that the buoys have, and also it allows you to update the firmware of the buoy and also has different alternatives to troubleshoot the information that you're getting in the buoy because we are, as such, we're in the development phase and moving to a production phase. So right now we still have the different tools for troubleshooting. Next one, please. Okay, so the next steps we have in the next step for our project, we have in prototyping, replace FTDI. That version of the electronics gave us a little bit of trouble. We have fixed the on-off circuit, manage a little bit more, work a little bit more on the power consumption so we can extend the life of the product. Fix the servo module design and field tests, different field tests with all these changes. And for the next phase, let's say the engineering validation tests, EVT, we have hardware and software integration because we're making changes in the software and the hardware. Implement notifications, include data logging, facilitate troubleshooting that is very important in this phase, and develop a phone application. And for the next phase, the design validation test for DVT, we have extensive, we want to make extensive beta tests, adjust the required depth, the rope, the ballast, and the buoyancy, depending on the application. We need to tailor or adjust the design for that and receive feedback for the features and improve the assembly instructions. Next one, please. Okay, finally, all the information about the project we have been documented, known instructions on how to assemble it, what is the process or the design, different information. We can find it in the hackaday.io link that we are having in this slide. We're also gonna upload this presentation to the main project that we're documenting on Hackaday. And we have the project page that I'm referring to. We also have a call for beta testers. That's a page where you can get in contact with us. And we have different repositories since this is an open source project for the electronics, for the software, or for the design. Next one. Now I will leave you with Erin that will finish the presentation.
Thanks, Leo. So that sums up ACHA version 2. And we'd like to give a big thank you to everyone who has helped and been a part of this project, especially SupplyFrame and Hackaday, Giovanni, Magenta, and Bruce. Thank you so much for all of your help to make this possible and make this an actual working prototype that we deployed in the field. It's been an incredible experience. Thanks to Jason, who locally here helped fabricate some of the pieces, including doing some welding last minute. So I'm incredibly thankful for that. And a big shout out to Bob, the Fisher, who has given us input and advice as well, and Clarissa and Ed, and our previous teammate, Toby, as well as Conservation X Labs. As well, last year we called on a lot of people in the fishing industry and people who have made ropeless fishing systems too, and they were kind enough to lend their time and experience to tell us more about it. And so we're grateful for that as well. So that sums up AJA version 2, and we can't wait to hear your questions and thoughts on it.
Awesome. Thank you so much, Aaron and Leo. It was really exciting for me to see the development of the mechanical design. I love the adjustment to the having everything around like a central axis. Axes makes sense for the spool and everything from the original more rectangular design. So that was exciting for me to see. And I just want to compliment you all again on your documentation on the IO. It's always been very impressive I know Giovanni and myself, and also, you know, just so useful for the community and for anyone who wants to get, you know, tapped into this project. There's just a wealth of, you know, experience and knowledge and solid, beautiful documentation, which we all know can be very challenging. So kudos to you all for that. You've set a really awesome example. And I want to pass it off to our guests to hear what they have to say.
All right, so I have a few technical questions and then some questions that are sort of more contextual. So I've looked at some devices that would be deployed in a marine environment. One of the things that we did look at was LoRa, and never got to actually test the range on the water of LoRa, but we had real questions about, I found it to be very temperamental on land in terms of ranges. And I wonder if you've done any testing on that in the water, or if you have any data, because I wasn't really able to find any practical data on what the real life ranges were on the water, particularly when you have your antenna is going to be so low to the surface.
Yeah. My answer to that would be that we have made some different some tests, but they are, I wouldn't categorize them as extensive. So I can give you a real answer on how will be the range, or if it's going to be or how it's going to be affected. We know that for smaller distances that we have measured them, it works, but on a measurement on how will be the real range, for example, categorizing if it's going to be like the real like it's going to be 3 kilometers, or if it's going to be in kilometers, I can give you a real answer on that because we haven't tested, and also if the coverage range, how it's going to be affected for the water. That's also another thing that we would like to test in the future, and we will have to prepare like a dedicated test for that, because by testing not only a different length, but also how it's going to be around the device at different lengths.
Okay, I'll be real interested to hear what you find out, particularly if there's chop on the water, which I would imagine could be an issue. The buoy, does it rise just by means of buoyancy? Is there any mechanism on the other? Is it uncontrolled? In other words, is it just popping up once it's been released? Meaning,
Right.
is there anything tightening the slack or loosening the slack on the part of the base?
The buoy ascends just using buoyancy, so no propulsion method there. And for slack on the spool, it's however long that line of rope is on the spool. So for example, if there's wind on the surface of the water, it is possible that it could extend out the buoy 30 meters or so from the base.
Which presumably isn't a big deal with the ranges you've got now, but if you go to the depths that you want to, maybe that becomes more of an issue. What I wasn't quite clear, you've added this accelerometer to the most recent version. What's that used for?
So what we plan to use the accelerometer for is logging data about what the underwater currents are like when the base lands. One of the pieces of feedback we heard from the fishers is that they're concerned about their gear drifting underwater when there's a ropeless fishing system attached. So in order to quantify this, we would need to gather more data, and that's the purpose of the accelerometer.
And why is that more of an issue with a ropeless system than it would be for rope?
It adjusts the buoyancy of the gear, is what they've told us, even though they are sort of separate systems that are just attached with a single line. But that's what the fishers have told us. So yeah, apparently it changes things. And,
okay.
Yeah.
And then the videos that you showed, they look like they're probably in freshwater. Have you done saltwater testing as well?
Sure, I can respond to this one for Canada. So these tests were conducted in freshwater, and in order to test in saltwater, we will need to apply for a scientific research permit from the DFO. So that would be one of the next steps to do. However, maybe Leo has additional comments about saltwater there.
Yeah, for the tests in the electronics, but without let's say the final enclosure and release mechanism, we have conducted them in salt water, but not with everything assembled together. So let's say, how is the electronics going to work in close or in the environment that we're going to use them? But I think you are probably more referring also about everything else with the release mechanism included. So if we're talking about the electronics, we have tested them and they are going to work. Now we will have to test also an integration that will be the electronics plus the buoy plus the base.
Right. So what I'd be most concerned about would be longevity, because saltwater is so brutal on kind of everything. It's a relatively expensive piece of equipment, at least the way that you've got it spec'd out at the moment. How's it going to hold up over years of being under salt water and maybe not being maintained as assiduously as you might like? So those are the technical questions I have. The contextual ones have more to do with the user. And one thing I'm not totally clear on is, what's the value add for the fishers here? Like, why do they want to have this system and why might they want to pay for it?
Erin, if you want to start with the answer.
Sure. So one reason why fishers may want to use this is because of policy. So for example, on October 18th, 2021, NOAA released some new rules, essentially, about lobster fishing on the East Coast. And in one of those, new rules, they said that now ropeless fishing gear is now permitted, meaning it is allowed. So you can see by that indication that there's starting to be a shift in adopting this new technology. As well, we heard from one fisher, and his fishery on the West Coast is unfortunately being targeted by an environmental policy group where all they do is lawsuits. And so essentially it's about how their fishery is like harming whales, essentially, because of all of the vertical lines. So they're being faced with this unless they somehow take action against it and fix it. So phishing has been around for a long time, and the same methods have been used for almost 100 years or so. So the first value add is that they will be on the leading edge in terms of technology and avoiding all of these policy issues. The next value add is that when the buoy reaches the surface, it sends out the GPS coordinates. So from that, you'll be able to, the fishers will be able to have a better plan about what gear and catches they're going to retrieve first, essentially optimizing their path, because there may have been some shifting with various weather patterns over the previous 24 to 48 hours that could change the path, where it's different than how they set the traps versus how they retrieve the traps.
Okay. So, and you've talked about talking with fishers about your design. How engaged and how many different kinds of fishers have you been able to engage with that?
Well, I will briefly answer your question, but I also complement something that we were discussing before. That basically the feature that we have had the most amount of interaction, really, in the areas where where they are fishing, or at least his company, they don't have as much of a problem with entanglements. And also, there is important to know that the fishers and these companies are very efficient on how they work. So, of course, we understand, and that's also the thing that we understand when we're working. So it is, of course, we know that adding extra elements to the process on how they work, that they have been working efficiently for a long amount of time, is not going to be as attractive for all the fishers, because you include something extra on how they work. Some of them are very, depending on the area where they have the problem of the entanglements, and some of them have less of a problem. And so we understand that some of them are going to be inclined to use the solution and also are going to be forced by law. And some of them probably are not going to see the benefit if they are in an area when they don't have entanglement problems, and they also have a very efficient way of working where they really don't, or basically if they are also don't have an interest on doing some maybe research or doing like besides the activity that they are doing. So now going back to the new question, basically the features that we have had like more contact with, as I mentioned, they are not in an area where they have a big amount of, or at least big movements or amount of whales or big mammals where they have that problem. So entanglement with bigger animals is not so present. But we still, from interaction with him, we got a lot of information on how they work and what things are important for them. And he's still, even though he doesn't have that specific problem, it's he himself, he's also like covered by the laws. So he still needs to find solutions for that. So basically he's still very interested, even though he knows that it will probably decrease the efficiency that he has right now. They are willing to consider solutions like this one.
Okay, I'll just make one sort of more, almost more of a comment, because I'm aware that I'm eating up a lot of time here, and I want Andrew to be able to ask his much more intelligent questions than mine, I'm sure. Which is just that. So if your focus is here, you're testing a device that where the value add seems to be largely in terms of, in human terms, for conservationists. You're going to tend to get pushback from the people that are actually the end users of the device, and particularly when you're trying to, if you're beta testing this with folks. And I'm putting myself, my parents used to live near Gloucester, Massachusetts, where there were a lot of lobster fishermen, and there were a lot of conflicts around those traps. And I'm just thinking about that as the audience here. These are folks with a healthy distrust of government. I'm sure that the fishers in Canada are much nicer, but in the Boston area, these are folks who have a distrust of authority and who are happy to thumb their nose at it. And if you come to them and say, I have this new device, which if it's successful will require you to use, they're going to be real resistant to that, and they're going to be looking for ways to kind of short circuit it. So finding more ways that this adds value for them and is something that they're really going to want, that's going to save them money, that's going to save their catch. And the only way you're really going to get at that is kind of sitting with the fishers and what they're doing and understanding kind of the taste and smell of what it is that they're doing and what their incentives are. Because from my, again, very limited exposure to that, it's different from what you and I might expect sitting here in, warm, dry offices on land. So that's all I have to say. Super cool project. I'll echo the comments about documentation. Documentation is supremely important, as I can tell you appreciate. Also, your prototype just looks great, looks super professional, looks really really impressive. So congrats on that. It doesn't look like something that was thrown together in a hackerspace. So good stuff.
And yeah, I could second that definitely. Congratulations on what looks like the kind of thing you might see on the nature documentary when you see those underwater robots and things. It is a device you can be proud of, I think, and I think your documentation is exceptional. One of the things I always like about the dream teams that Hackaday is able to put together is how international it is. And what you're talking about here is an international problem. So, I'm really glad that you spent this much time focusing on it. A practical question, and then some general questions if we've got time. When you're talking about the sensors on the device, I've got this image of you have your pot and a lobster or a number of lobsters crawl into it. How does it, is it literally just a timer? You wait for a week, you wait for a month or something, and then it releases? Or when you talk about other types of sensors, how would you, what might that be that could help detect whether you have lobsters in the pot? And because with all of the movement of the water and all of the is it sound, is it what would you detect?
Well, that's a very interesting question. For the design that we have right now, in the state that it is right now underwater, we have the timer. We have only the timer because the water affects all the signals that it's receiving. So unless you have an acoustic link with the design that you are exchanging information, really having other sensors that will be transmitting is not really a good use for you, because you're basically not going to get the information. You could extend, and that's another thing that we have been considering, that you could extend the design and include other sensors, maybe like a camera, or maybe extending it for something, let's say for something like a camera. And I don't want to get into if using processing the images. That's also something that you could do, but you could also have image on the environment depending on the camera that you have, and also take interact and use the camera in a way that you are documenting something. But when you get to the surface, it's basically when all the electronics really the rest of the electronics shines, because you're in an environment where you can extend, where you can communicate and get information.
Yeah, it's a really pretty fun technical challenge, that, and I can see why you might want to do a sort of third iteration, you know, to explore some of these ideas. Erin, did you want to add something to that?
Yeah. So in addition to what Leo said, something that was a little mind-blowing when learning about this sort of fishing area is that the traps are only baited to last for 24 hours. So they're only attracting lobsters for a day. So imagine if there was a way to do timed release bait where the traps could then stay underwater for maybe 3 days and then have a sensor that would say like, okay, now it's time to release some more bait, and it releases some more bait. That could save the fishers so much effort on them like needing to go out every single day to retrieve the traps and then deploy them again. If it was sort of an intelligent way to like bring the lobsters in, it would just be amazing. Yeah.
And that speaks to some of what Rob was getting at as well about other incentives that you can create, because, you know, in that circumstance, you could imagine a fisher that's able to, you know, manage so many more pots for, you know, traps, for example. Thank you. I need to explain, we have a festival in the UK, I'm in London at the moment, called Bonfire Night, where we celebrate, I think, although I think the attitudes have changed towards this, but I think we're trying to celebrate the Parliament not being blown up by Guy Fawkes. And so we set off fireworks. So if you hear loud bangs and explosions, don't worry, I'm just in London, it's safe. It's fireworks going off. I really like the documentation, like I said, and I'm curious as to sort of what is it that brought you back to this problem and to do even more documentation. You know, what is it? Is it and even to the extent where you were designing, I mean, that was really impressive, your own you know, GPS boards and things and integrating them. I think the cost is going to come down. The cost is going to have, you know, the number of pots that are out there in the world, the cost will come down. So I think you've been a little bit unfair to yourselves by quoting a $2,000 price tag when in fact you could see these things having a market. And I'd be interested to see any, you know, trials that you could get onto where you might be able to deploy 100 of these things or 1,000 of these things and show the impact of it. Sorry, but yeah, what is it that keeps bringing you back to this problem?
Well, while you think about that, I'll just add to what you said, Andrew. I'm really proud of the team. They did an amazing job with this, and all the boards that you saw were designed by Leo entirely, and he had to, everything from scratch, firmware included. So yes, in a record time. And I remember talking about documentation, it's not only designing something with a really small footprint so that it would fit in you know, the bottle that they're using, but also time constraints and having to send this information for PCB manufacturing on a Sunday night. I would ask Leo, hey Leo, please send me these on Sunday night so that I can send them to China and they can be working on them Monday morning over there. He would, you know, magic. He would do his magic and have those boards ready. But then, shortage of electronic components. We have to change this. so there was a lot of work.
Yes, you had lots of challenges to overcome. So you must have been pretty motivated. And you know, is it the conservation angle, the technical challenge, the maker angle of it, the international nature of the team? What was it that was drawing you back?
I would say the most interesting things are the first three that you mentioned. Of course, the conservation goal, the idea that we can really make something that is gonna help to make an impact, and really provide a solution or a part of a solution to a problem that is very important in the world. So this is the conservation side, but also the technical challenge. I think they're also very interesting for us because they push us to make something better and to consider different ideas, or even to make something better that we currently have. Of course, for fishers, but also in technology in general, because like Giovanni was mentioning, a lot of the effort and making different boards to test circuits, but because of the shortage that we have right now, that not only extends to like graphic cards and expensive computers, you also have shortage of microcontrollers and GPS and different things. So
yeah.
It was more like, we can't use the one that we have right now, and we have to consider one option that is going to reduce the cost. But at the same time, we need more than one, because if while we're designing for one, then that one goes out of stock, then we won't be able to finish what we're doing.
Well, that's also an important principle for open hardware, that you don't tie yourself to any one particular supplier. Thank you. Yeah, I can see why you'd be so excited by some of that. And Erin, in your case, what was it that brought you back to this again?
Just sort of like the nature of leveling it up. So we were able to prove the functionality with version 1, but it wasn't quite something that you would want to see replicated more than like twice, just by nature of how many mistakes there were. The idea of like being able to level this up, like with the mindset of you're designing it and you're designing it to be manufactured. And there were so many points along the journey where in the CAD design, I would just end up scrapping the whole thing and starting over, just because I realized one mistake would have cascading effects in terms of manufacturing. Additionally, like the name suggests, Dream Teams, it's been so much fun working with everyone. Like, it's international, but yet it's just so much fun because everyone is working on like what they're passionate about in terms of the technology. And then we always learn something from each other. And I think that's been one of the most important points. Sorry, one more thing is also the exploration aspect. So there isn't currently a lot of methods to do inexpensive benthic monitoring. And benthic monitoring is a little bit of a different approach than underwater ROVs, because benthic monitoring needs the sensors and the device to be active throughout a longer period of time than just the time duration of an ROV dive. And so that's also been exciting me, like the exploration aspect, get to see things at the bottom of the seafloor.
Well, I think that's really exciting. Thank you so much for saying that. And there's fireworks going off here to celebrate your success. And yeah, I think this idea that you're bringing some technology into a problem that has been around for over 100 years, that it's been really hard to find any solution to this problem, and that you found something here that could potentially scale. That focus on design for manufacture. Often, people working on open hardware might work on a single batch product, or a single item. The idea that you're trying to design here for something that scales is really important to me. So I'm really glad to hear that. Thank you. Well done.
I just want to check in, Rob and Andrew, do you have a few more minutes, or are you tight on time? Okay, just want to make sure, because I sort of have a question I want to throw back at you guys. And now I don't know if you can hear the ambulance going by or the fire truck, but we also have some background noise. But I think that something that's been a challenge and has sort of come up in the discussion at this event and also in their last presentation is sort of like the chicken or the egg with prototyping and user testing, of course, and has been extra challenging with the nature of this this project and the types of users and like Aaron mentioned, the permits and other logistics around that type of thing. So I think they've done, the team has tried to do sort of open call to people that might want to get involved and help test the device or build it in different places if they have access to different types of waters and things like that. But do you all, Rob and Andrew, have any tips or tricks in balancing that, sort of compromise between wanting to get your prototype to the next level, but also, of course, wanting to integrate feedback as you go and continue to make the prototype, more efficient, but also be able to take in those adjustments or ideas from the community.
Right. So, and I think it is an important thing, and I think it's something that so the Hackaday community is is super technically sophisticated, has a lot of that technical talent, and is able to deploy it in incredibly creative ways. My experience is that the really difficult problems are almost never purely technical problems, because if they were, they've been sorted out already. So those issues tend to have complex overlays on them that may be economic, they may be social. Most likely they're a combination of different factors that can be incredibly complicated. And particularly, so here's a case where me and the typical engineer, I'm not familiar with what a fisher's life is like and what their workflow is like and what's important to them. But I can guess that it's very different than mine, and they're going to be much smarter than I am about a lot of things that are really going to affect how they use the thing. The other piece of this is that, and as Andrew pointed out, this is a worldwide issue, but I guarantee that the way that they do this in some places is different from how they do it in Canada or in the United States, and that may also be something that you want to explore. So I always try to get the users involved as early as possible, because I find that often they will come up with ideas or priorities that I just never would have thought of, that I just wasn't smart enough to know that they needed. And again, with something like this, where you're trying to get a take up of something that isn't going to be inherently I wouldn't say, a lot of these users are going to see that as contrary to their interests. A lot of it's going to be kind of, providing them with value that is going to make them want to use it. So that to me is a critical thing. And from the perspective of Hackaday and SupplyFrame, it seems to me that one of the things that that you can really provide with the Hackaday Prize and with these challenges is I think that the community has a lot of the knowledge and access to a lot of the tooling that they need in order to make the things. In many cases, they probably don't have access to the problem, to the user, the end user, and that's where that's why I think the partnerships that you've created with organizations like Conservation X Labs, where they do have some interface with the user, is really important. But looking at how do you connect these problem solvers with the problem havers and the end users of those solutions, I think is really important. So my own bias is toward integrating the user as quickly as possible and as often as possible.
Absolutely agree. I think the idea of working through those partners like Conservation X, in my work at Field Ready, we tend to work through the people who are actually managing the refugee camps, the people who are the local governments, the local government officials, and or even the sort of the disabled people's organizations or the community representative organizations. That's how we begin to sort of engage with knowing the need. I think one of the things is to just manage expectations. Make it really clear that what you're doing here is essentially like a science project, and that you aren't going to be able to give any numbers about what this is going to cost them, how many lobsters they're going to need to catch to make an investment in this thing worthwhile, you know, because it's too early to tell. And, you know, giving the information that you have now might actually come back to haunt you, because you know, excuse me, you know, the cost of a prototype is so much higher than the cost of a production version usually. The other thing I would say I get away with quite a lot is talk about it as doing an experiment, you know. Excuse me. Talk about it as not a commitment to buying this product in the future, not a project that they have to get on with for, you know, for the next 3 years. Talk about it as an experiment. Let's see if it works. Let's see if it works for you. People will respond to that.
And typically they want to be heard. They want someone to listen to what their problems are, and tend to be very receptive to somebody who's willing to do that. So I often find people are surprisingly willing to share their time with an effort like that.
Thank you. I think that's really good insight, and something that Gio and I discuss a lot when it comes to the prototyping process and talking with users is definitely sort of like not having something too refined too soon, especially when you're approaching, like you all said, approaching these community members or the users, of course, because people, it helps manage the expectation. If people see something that looks super polished, ready to go, then, you know, what's their perception of that going to be, that you've already solved it and you're trying to sort of push this on them or something like that.
Yeah.
So I think that's really key is how you frame it and what's your how you approach the initial conversation, like you said, Andrew, as an experiment or a collaboration or something like that, of course.
And if you can find ways to help the people who are using it to have some ownership of it, if you can get like a nice feature that they propose, like, or even just a logo or an image, a picture of a lobster on it to make it look a bit like, and you know, something that will help people understand that they are part of that creative process. I think that can be really exciting for people as well. That can be really sort of, all right, I'm an inventor, I'm a designer now. Maybe I could join the Hackaday community.
You know, Andrew, that's a fantastic bit of information there. I remember one of my very, very first jobs when I think I still was in high school, and I started doing sales for a friend. And I asked him, do you have a tip, like something I can use to sell more? And the very first thing he said is slap the company's logo on the thing you're trying to sell, because that gives them, you know, that makes them see it how it would look like. And I'm not talking about slapping a logo on this just for the sake of it, but as you said, getting people involved, listening to them, just as you said, Rob, and including those features, making them specific to certain geography. It can energize not only fishers, but an entire community.
People who create, people who can take part in creation are happier than people who consume. So if you turn up and give them a polished product, you know, that they have to then buy, you know, it's a different, you're starting the conversation in a different place, and if you can create something together.
Absolutely.
Fantastic.
Well, thank you so much, Andrew and Rob. If there's no other last thoughts from anyone, we'll wrap this up. I want to be respectful of everyone's time and the rest of your day, where everyone's tuning in from. Yeah, Gio, one last thought.
Sorry, I just wanted to, I think I won't have the opportunity later to do this, but I really want to thank the team, Erin and Leo. Your effort has been, and your dedication was fantastic, and your professionalism. Both of you were extremely committed and also capable. As you mentioned, Erin, you you two had your own areas of expertise, and you devoted your time and your energy to this, and it shows, so it shows in the documentation, in the product, in the videos, in the solutions. You can explain everything on the product, on the mechanical components, Erin, from the bottom to top. Leo, you can explain everything that's happening on the boards, and that's no small feat for something that was done in less than 3 months. So shout out to you guys. Really proud.
And by working remotely. Yeah.
And working remotely, one of you in, well, not separate continents, but Venezuela and Canada, you're not neighbors, and we have COVID and we have shortages. So what an adventure this has been.
Thank you very much for your words. And I think we are really giving our all to the project, because we really want to make something that is going to be useful and also learn from the experience, but also provide something and create something that might arrive to something bigger, to a solution, to something that the fishers can and are happy to adapt, or at least they see the potential in that. So we are really giving our efforts to really solve all the shortcomings. And also I want to thank you, Giovanni and Magenta, for all your mentoring and all the information that you're giving us to try to also make a great design, a great product, and take advantage of the opportunity as much as possible.
Thank you so much, Erin and Leo, for your amazing project and work. We're excited to see where this goes. And even, if someone else or a community member takes it on to move forward, it's, like you said, going to be an awesome step in the, the long-term journey of trying to make an impact on this challenge. And thank you again to our guests, Andrew and Rob. And of course, to our sponsors, SupplyFrame and DigiKey, for continuing to support the development of open source hardware and our collaborations with different nonprofit organizations through the Dream Team program. And thank you to my colleague Giovanni, always, for managing all of these things and helping us tackle all the different challenges within the challenge, like you said, logistically and the remote collaboration and everything. So it really has been a team effort, and I'm so proud of everyone who's been involved. And as Erin and Leo mentioned, if you want to get involved, you can check out their project on hackaday.io by searching EDGA or Hackaday Prize 2021 Dream Team. And you can also contact them there if you want to learn more or get involved, as we said again. And one last reminder that Remoticon is coming up in just a couple weeks on November 19th and 20th. There's going to be lots of awesome speakers and activities and ways to chat and virtually party with all of our awesome community members. So check into that. And thank you all again for joining us.